Just make sure. Cool. Okay. Okay. So now that we've started up Jupyter Notebook, now, and we've also started it up from the directory where all of our repositories, or all of our notebooks have been stored, you should be able to see this screen. And if not, I'll troubleshoot with you afterwards. And what we have here is we have the Python directory, and then I've got 4 modules that we're going to go up. Last class we just talked about setup and how Python works. That was module 00. We're not going to touch that one today. I think we started going into some basic Python syntax. So I'm going to kind of touch on these pretty quickly and just tell you the highlights. Now, I'm not super brilliant, I promise you. I'm probably the worst coder in this hangout. Probably the worst coder on the East Coast. I'm just going to be very honest. So a lot of this stuff I wrote from being a simpleton, and I also copied some of this stuff from that handout and that PDF file I was talking about that's on the GitHub that you can download from. So I'm using a lot of different resources in here. But things I just wanted to make sure, commenting, make sure your comments are done with this. And the other thing I wanted to kind of show you too is how Jupyter Notebooks work. I think we touched a little bit on it last week, but I want to kind of show you why we use Jupyter Notebooks, and not just instead of just using, I can use an editor and write code like this. I like doing Jupyter Notebooks because I can document and comment. So so basically what I've done here, just to show where I am, I went into Python, I went into QLX, I went into data science, I went into Python, I went into module 1, and then I clicked on Python syntax. And then what we have there is at the beginning of this notebook. Now, what's great about this is that this notebook itself allows us to write code in it and that kind of thing. And how do you know? So you'll know that this section here is, you'll notice when you look up, it basically says it's markdown, and we're writing like HTML code to be able to mark down and to be able to execute it. I just hit Shift Enter, and then on this section I have code. So I can write code. I'm just going to do a really quick stupid hello world. Let's just do that. And I'll show you why I like it this way. I know we've already covered this. I just want to make sure we do it really quick to show those people that maybe have and what I did was then I wrote the code. Notice that it says here code, and then basically I push Shift Enter to execute that. And what's great about it is when you save this, it saves those exercises, and you have all the context around that too. Okay, so that being said, if you wanted to create your own exercises or be able to create your own little notebooks, super simple as well. While you're in here, and you can do this from anywhere as long as Jupyter is up, all you have to do is go File, New Notebook, and then you choose the language that you want to write that notebook from. You probably won't have all these selections. I've actually personally installed Julia, JavaScript. I got to make sure that my R is working too. I notice the R is not showing up there, so I'll fix that when we get closer to R. But what this means is when we create a new notebook, it's going to find the engine for the coding language, and then it creates it. So you'll notice that every time we do something here, this Python icon is here, and of course Python 3 is showing to show what coding engine it's using to render this code. And it's very important, like I said, that we're using Python 3. We don't want to use Python 2 because it's end of life. So let me just to kind of give you an example, and let me do one. And I want to show you one more thing. Again, this is just an example. If I wanted to title, I can do. I'm using markup language here, and I'll show you. There is a file that I use. If you're wanting to know how to do markup language in notebooks, just to write your own code and do all of those things, I've already supplied that for you. If you go to your GitHub location, that link, the big link, you'll see, and I'm just looking at the main link here. I've created a file called Markup Language Cheat Sheet. It's a PDF. It's on our QLX website that I put it there, and it shows you how to write all those headings in there. I know I'm throwing a lot of stuff at you, but I just want to kind of let you know, you can write little notes to say, talk to me later, like, what were you doing when you showed me this? And so do like this. And then what I want to try to do is show you, I can do x equals 1, let's just say print x, and boom, it does that. And then what we want to do is we want to save as. Now, this is also very important because normally when we're creating a Word document or Excel spreadsheet or a SAS piece of code, if I call this exercises and I hit save, it'll put that .sas or .doc at the end of it, not with notebooks. With notebooks, when you do a save as, you have to put the IPYNB. IPY stands for IPython Notebook. And once you save it like that, then it's no problem. It will save. But if not, so for example, we had a lot of students in my last class. They are like, oh, I saved my stuff, but I can't find it anywhere. So for example, if I do a save, and then I come back in here, oh, well, it did save it on that one. Anyway, maybe I'm a big liar. But normally I had some problems with some of the students, and you can see that the exercises did put the extension, which is good. I like to just be safe, and I like to put it in the same IPYNB, and then save it like that. And all I did there is I created my own notebook to be able to write my own stuff. So, and I saved it in the mod intro directory. So anyway, I do want to show you that before we get started. And I'm going to pause because there's a lot of people on here, and I know I'm going pretty fast. Any quick questions or anything that I can maybe touch base or show you one more time? No pressure. Okay. Now, let's just go through some highlights, some really cool stuff. And yeah, let me show you some of the comments. So we talked about this. Comments are important. Comments are you use the hash to do comments. End of line, basically what's great about Python is it will continue to read the end of line, especially if you have an open parentheses. It will keep looking to the closing of parentheses. You do not have to use semicolons if you don't want to. Just like with the SAS code or any other things, you can leave it with a semicolon or not a semicolon. Does not matter. Clean and pristine is the white space. Doesn't matter. Parentheses are for grouping, especially when you're looking at the operations of how things work. So you basically want to use parentheses, especially when you're using Python 3. Python 3 requires parentheses. I'm just going to touch some really big things here. Now let's talk about variables and objects. And all these things, all I'm doing is I want to show you these because I think of these notebooks. And what I did was there, by the way, if you're wondering, well, how did he get there? I'm just clicking on the link. So I've actually created all these links for you in the notebooks to take you from place to place. So it's not a website, but it does have hyperlinks that takes you back and forth. And just to show you, I have a table of contents. So if you need to get to a certain place, I've built that for you as well. And I just use all this as cheat sheets. Just basic cheat sheets to get through it. And the reason I'm walking you through it, because I know you can all read, is I want you to kind of like, mental note. Oh, that notebook has this. Oh, that notebook. Because I don't want you to memorize this. I want you just to be able to reference it. So just note that what all the Python is doing as it's creating variables is a pointer to everything. So x equals 4, which is an integer. X equals hello, which is a string. So that's all we're doing here in Python is creating variables that point to things. Simple. Most coding languages are, which is fine. And everything is an object. So it's object-oriented. In Python, everything is an object as we go through it. So just hitting the highlights. And what you can see here too is that, and we're going to get into some of these. So we're going to be talking about data structures as we go through the syntax around how to store information and that kind of thing outside of a database. We'll get into the database stuff a little bit later. But you can create a list, and then you can have, there's functions within that called, like for example, append, and I have some cheat sheets for that, where basically you can add to a list at the end. And append only allows you to put it in the end. So I'm just giving examples of, I don't have to define a variable. I can just say L equals this list, or I can say, and it's automatically defined. Is there anything here? And I also, in this second one too, I've actually shared with you some secret links. So there's a pie format function that you can do, that you can format information really, really quick, which is the same thing as we do within SAS. Sorry to keep bringing SAS back up, but you're able to format data in different ways. I put the link here. It has some examples. We really won't be doing pie formatting until a little bit later, but I wanted to make sure that you know that as you're creating variables and objects, there is a format for that. And operators. Operators, of course, is the one we're doing arithmetic and, you know, the super duper math stuff, and that's where the, you know, and this is where I find the difference between Python and R, because with Python you can do your mathematical calculation, calculus, all of, you know, the algebra, all of that stuff. I like to go to R because that's where the heavy-duty stats are. There are some stats modules within Python, but for the most part, I like to do my data work, prep work, web work, scraping, Python. Then once I get my data into a place, then I go to R and do the heavy-duty stats, which is what we would normally do with SAS. We can do the same thing. I can use Python to get my data ready, and then use SAS to be able to do the statistic work if that's what you feel comfortable with. The reason why you would do that is there's so many awesome modules that you can add to Python that makes your life a lot easier. And you know, if you remember the first class we had, on that there was a link that I showed you that you can do a search and find all of the available Python packages that you can download. But anyway, the math stuff is basic: a plus b, a minus b, times b, true division, floor division. You can do exponentiation, be able to do exponential like a to the second, or 3 to the second power, and all you have to do is 2 asterisks. Negation, which the joke I always make is urinary plus, which I don't even use or know about, but those are the types for that. Especially, I think, you know, Barry's the professor. He probably has done this. Not to put you on the spot, Barry, but I was just saying, yeah, anyway, that's some of the other things we can do. And you can also say that the order of operations is very key by using the parentheses around it, which is something to remember. So this is totally different than 4 plus a, which I know pretty much this is the same for all coding languages. So if I go 8 times 6.5 minus 3, it's a totally different number. So the parentheses really can change the order of the operations as you do this. And of course you can see the true division, print division. There's bitwise operations. This is kind of above my pay grade. I'm not doing much on this, but you can change on the fly a number into its binary counterpart just by putting binary 10 or, you know, whatever the number that you're looking for. And of course you can change that into a binary number if you wanted to be able to use that, which is really nice. And you can assign, which we already have seen this a million times, a equals 24. You can print that out. What's nice about Python, though, which I think is kind of cool, is you don't have to assign it first. You can just start going for it. So if I say a equals, so let's do this. So basically I'm going to assign, I have to first of assign a equals 24. So I'm going to do that. But now what I can do is, if I just wanted to go with this, I can also do, and then I can say, so I don't have to redefine it, I can say print A. Cool. So what I can do is I can reassign it on the fly to say what I wanted to do. And here's the other thing too is right. So what I wanted to do, let me try something here too. Let's change this back, get 24, I'm adding 26. So what I can also do too is if I wanted to be able to add more, you can also do the plus equals to be able to do the exact same thing over and over. So it's really nice that once you do it, but remember these are how would you say? These are mutable, which means you can change them over and over and over. They're not immutable. We'll get into that a little bit later. So variables can be interchanged. And remember too, never create your variables beginning with a number. Python will just give you an error every time. So if I create this as, just to let you know, 1A, it will give you an error. So you have to make sure everything starts with a letter, alphanumeric, and then you can do it like this, and then it should not be a problem. Cool. There's comparison operations, the same as C, some Java, those kind of things where you're basically A is equal to B, A is less than B, A is less than or equal to B, so you can see all of the same operations. So I want to just let you know here. There's Booleans where there's and, or, if this runs, then do this, that kind of thing. So there's the Boolean operations, and notice what we're doing there is with parentheses, and parentheses, that type of Boolean thing, which we'll get into. And then there's also identity and membership, being able to see if something is, if I create a list that's called A, and then I create a list that is B, is A and B equal to the same? If you want to be able to match those up, and you can do that. So if I, just to let you know, I'm creating a list, and then if I wanted to print B, just to kind of show you that it's been defined, which it has been, and if I wanted to define it as A, A, just really quick, you got this, so you define it that way. But how about this? So I'm going to create another number, and then I'm going to, and if I do B, notice that I have two lists of numbers, and then if I run this program to see if the identity and membership of that, let's say false. A, the list of A, does not equal the list of B. However, if I did this, of course, just doing some basic stuff here, and then it will say, hey, these lists are the same. And what's cool about that is you could also do this if you wanted to kind of go crazy. I could go A equals B. And so I've created a list called A, and now I've created a list called B. And now if they're equal to the same. So just to say there's different ways to skin a cat, but all we're showing there is that these lists are identical in every, identical list. Yeah, so, and I did this too. There's a way, if I wanted to, let me look at this. I'm going to get rid of this for a second. There's also a way to say, instead of A equals A equals B, we can also say is AB, and it will actually answer true because we defined it up here as being that. Okay, the other thing that we can look in is membership to see if one is part of a list or another number is part of a list, that kind of thing. And that's it. So I guess I think that's, let's correct me because I don't want to waste everybody's time. I think this was, did we cover all of this last week? Can anyone tell me yes or no, or just put it in the chat? Hello? Julian? Yeah. We covered all this, correct? Yeah, okay, great. Yeah, okay, good. So we did have practice exercises that I think I've assigned to everybody. And I just kind of want to walk you through those. If you didn't turn them in, that's fine. Don't worry about it. What we're going to do is I'm going to show you the answers to those so we can kind of talk about what we're doing here. And some of the exercises that we did, they're kind of going, we didn't talk about all of the things I wanted you to Google. One of the things you can do really easy with Python because it's so prolific, you can put something in Google search and the answers will pretty much come back to you. So I normally tell people you don't have to write code from a blank slate. Just put in your idea into Google, say Python at the end of it, and there will be some code snippet that you can cut and paste from, which is really nice. So for this one, what we have is the first module for the practice exercises was I'm defining, and I can just call it this. I'm defining, asking the user to input a first name. I'm just defining the variable, saying input, put a little bit of text in there to kind of prompt them, and then I'm going to create one called last name input, and then basically I'm going to say a print, and of course it's super easy. There's nothing really crazy about this, but you can see how easy the language is when we do this. So I'm going to say, I think this is my Indian name. I have when I was living in India, they gave me a Brahmin, I don't know what, but Brahmin is Vijay Agastya. So Agastya Vijay. Anyway, so what we're doing is that. Now, and what I'll do is, what you should have done is you should have downloaded this, so you should have these answers already for you. So some of the other exercises we won't, but I just wanted to make sure that you have these examples for you. The other one is you want to accept an integer and then compute the value as it goes through. So n plus n times n, and then n. And so it's very simple. We're defining I can actually call it like this to keep it simple. What I want to do is I want to create an integer. I'm going to accept that integer, and then what I'm going to do is it's really super simple. And let's talk about that. So what we're doing is I'm creating a variable n to get a user input. Then I'm creating a new variable. I'm defining to make sure it's an integer, because very easily things can be converted to string and that kind of thing. So I'm defining it as an integer. I'm printing a little bit of text so they can see that, and then of course doing for n, and then I'm doing it for n2 and then n3, and then you can see everything being added up together. And then let's just say 492. So super simple, easy to be able to do some of these Python programs, pretty easy. This is the same, defining a country, printing it out, super easy with that one, string input, what country you're from. And now this is probably the only time that I will do this. I think in the next class I'll have you guys show me what you built and what you do. We'll do some kind of sharing of the screen there. And the only reason I'm doing it fast now is I just want to get you into lists and tuples and sets and dictionaries, which is our data structures. The next one that we did is you want to write a loop that multiplies the number 4 by all the integers from 0 to 10. What we're doing in here is we're going to create a loop. I think it's pretty straightforward. Creating the variable n, and then we're going to go I in range. And notice that we're doing is we're going from 1 to 11. Basically creating that set, and then we're going to print the integer times the increment that we're going through, and then we actually multiply it to it. And so if I wanted to, I'm going to change this up. I'm going to change it from 4. It looks the same, or 4. Here's where it gets a little harder, and this is where my OCD, I like my OCD a lot. So we wanted to create a multiplication table, very similar to what we did up here, but what we want to do is we want to create a range. So we want to iterate through 1 through 10, which is using this range 1 through 11. And then what we're going to do is, while it's in that range, we're going to print what the result is of I plus j. So basically what we're going to be doing here is 1 times 1, 1 times 2, 1 times 3, vice versa, and then printing it out with this little white space character for tab. So we're actually creating a tab space between those, and then we're printing it out in a kind of a format like this. And to be honest, this is one of those you can look up and do a Google really quick to be able to find out if we wanted to do spacing and multiplication tables for that. We can even make this a little bit larger if you wanted to. We don't have to. I'm just going to show you, and we can actually create it a little bit bigger going through the range there. Oh, I'm sorry, and I forgot to do it here. If we wanted to make it 15 by 15, there we go. So or 14, I'm sorry. 1 through 11 is 10, 1 through 15 is 14. Okay. Blah, blah, blah. Hopefully I'm not putting you to sleep, or I am. And just let you know that if I am putting you to sleep, this will be the best sleep you've had all week. Because there's nothing that puts people to sleep more than people presenting on a Google Hangout. Anytime we're presenting. You thought it was bad being in a class after lunch. Getting on a video conference is probably the very worst. So what we're going to do here is, now that we've finished with this notebook, we're going to go to table of contents, and we're going to go and we're going to look at data structures. Okay. Now we touched on these earlier, really quick. Same thing as most of the coding languages. There's integers, there's float when you're using decimals, there's complex, there's Boolean, and there's string, which is like characters. And then, of course, there's a none type, which I've never personally used. Maybe others have, but I've never used the none type, but it is available within Python. It's a special object indicating nulls, if you wanted to be able to use that. Integers, of course, you just, once you define it as a, you define the variable as x, you type it out, and you can say, what is the type of that? If we wanted to be able to go and say, hello, then, of course, it would show that it's string. So you can tell by just using the type function to be able to figure out what it is, to be able to determine what that could be. There's also, if you want to be able to do 2 to the 200th power, or whatever you wanted to be able to do, you basically use asterisk asterisk to be able to go through that, or if you wanted to go 2 to the 10th power, there you go. And then, of course, by default, division upcast to floating point type. So it's always going to go, if you are dividing it and it's basically a decimal, it turns automatically that variable into a floating point, which is kind of cool. I think SAS does something similar. I believe so. It's been a while from that one. You can do floor division. Floating point numbers can be stored fractional numbers. They can be defined either in standard decimal or in exponential, which we're okay with. We're not going to get too deep into that. And you can actually convert an integer into a float and vice versa. So if I wanted to be able to change, let's do this. I'm going to do two things. I'm going to do integer and do a 1.0, right? And then if I wanted to do, get rid of this, and if I wanted to convert a integer into a float, you can do the same. Okay. The other thing to note too is there is a little problem within Python. It's not. So one thing to be aware of the floating point arithmetic is that its precision is limited. So basically means is if we do a 0.1 plus 0.2 and is that equal to a 0.3, it will say false, because as it looks at that floating point number, it actually is keeping it all the way down to, I think, the nth degree. And so as it does the math to do it, it will basically say these two numbers do not equal these two numbers at that fractional level. So just to be aware of that. We'll be getting into some of the workarounds around that a little bit later, but I do want to make sure that when you're doing this, to be able to check to see if these two things are equal to this, it can cause some problems there. There's complex numbers. I don't want to get into that one, but we do have it listed here for a complex. And of course, string type, you can say, you can use single or double quotes, doesn't really matter. Make sure your single is with single and double with double. Yes, and you can do concatenation with strings, which is great. So basically you can say, all you have to do is to define a variable called message, define a variable called response, both a string. You can ask for the length of response, you can ask for the length of message, which is 17, obviously. Then you can, there's an uppercase. I like to use capitalize. So basically I can take that response or that message and with that function response, and then I can capitalize that, and then I can concatenate both those variables together. And also, if I wanted to be able to put space between them, I can do that just to kind of keep it neat and clean. And if I wanted to do capitalize, just really basic stuff. Okay. And if you want to multiply that, so if I wanted to take a string and multiply it times 5, not that I would want to, maybe you want to, this would be good if you're using, so for example, let's do, I got an idea, let's call this space and call it NSB, what is it, NBSP, right? And then basically I want to, this would be if I'm doing like some HTML stuff, you can actually push that, those HTML characters, or adding space within a URL, pull or push using the NPSP. Okay, and you can also, if you're creating a message, you can actually access each letter within that variable too. So if I wanted to be able to go, and remember when you're looking at a string variable, it's like Europe or rest of the world mostly, all elevators in Europe and South Africa and Hong Kong start from 0 and go up. Ground floor is 0. Same thing when we're looking at strings, or be able to look, you're always starting from 0. So the first character would be 0, not 1. And so we would do, we can look at that, or if I wanted to be able to put, let's say space, and cool. All right. None type, I'm not going to really return that one. None is, none type can be used to kind of, if you want to clean out a variable and just make it null, none type can be used in that. If you just want to, if you haven't defined it, or if you've been using it over and over, you can use none type to clean that out. And of course Boolean type, which is basically if you want to be able to see if something is true or equal, and or. So yes. Okay, blah blah blah. The one thing I did want to show, because before we get into the cool stuff, which is lists and tuples and stuff of that, and again, I'm going pretty fast here, but and I can always do some stuff at the end of the class to talk to anybody. You can convert, just like we were talking about, from floater to integers, and that you can convert an integer to string, but you can't convert mixed case, obviously. So if I wanted to change 10 and p to an integer, you can't, you'll get an error. But you can basically use them in conjunction. If you wanted to be able to put user Jackson and lines as 100, you can say, hey, I can convert the number of lines into a string to be able to print it right. So for example, if I did this, and I run this code, it'll give me an error because I'm having an integer, which is lines, being shown with strings. That won't work, so I have to, there we go, and convert it to string. Okay, now, how are we? I just want to, I'm going to pause for a second. I feel like I'm talking to myself, and I know a lot of this stuff is basic, so I want to, my goal for this is to remind you is if you've coded in SAS and C and Java and COBOL, maybe COBOL is going too far back, a lot of the same things apply. So that's really what the goal of this is, not to be intimidated by Python. All the basics in this is still set up. If you've never coded in those languages, don't be afraid either. That's what this notebook is for, so you can kind of read up on it and try to do some, you can get some examples for that. So those are the simple types of how Python works. Now, before we go into data structures, any questions, any issues, anything that's crazy? I know I'm talking fast, but I think I've got like, and I can go longer for the next class if you need me to. I think there's a question there. Let me see. Thanks. Okay, cool. Thanks, Julian. And the reason I'm just doing this really quick, I'm trying to cover 2 modules because most of it's documented, and then I'm going to give you a kind of an exercise. Probably will be tomorrow. I've got some exercises already there, but there's an exercise I want us to start working on for customer lifetime value that I'll be giving you tomorrow to use some of these things to get started with. Okay, and let's close out of all this. And let's go back to where we're doing built-in data structures. So, built-in data structures have 4. We have lists, we have tuples, we have dictionaries, and we have sets. List is exactly what a list is. Lists are a basic order. They're mutable, which means they can be changed modified, and they're basically just a data collection that can be defined with comma-separated values between square brackets. And that is the key, brackets. Whenever you see in Python that they're putting it in brackets, note that that is a list by default. That's what it is. You can put lists in lists, but the brackets define that that is a list. And you can put combination. It can be integers and strings and all of those things. And you can even define, you can actually see what the length of a list and how many things are in that list by using the function len, just like we were using earlier. You can do the append, which always appends at the end. You can't, there are some functions we'll call pop that we'll talk a little bit later, but basically allows you to be able to append things into that list. And you can also concatenate lines. So basically you can have a list called L, and then we can add more to that list. Remember, lists are mutable. They can be updated, changed as we go through. And note, the key there is brackets define what a list is. And you can also define, you can do a sort of that list. So if you're doing a bunch of integers, there's a function already to sort, and you can do it, in lowest to highest and those kind of things. And you can do a combination. I can do floating, I can do integers, I can do strings, and I can have a list within a list within this. And if I wanted to print this out, it will, of course, tell me all the things that are in there. And we can also be able to index and be able to call other things that are in that. So, for example, if I'm creating this list here, L, and then I have all these numbers in there, remember, with lists, just like what we were talking about before, starts with the elevator at ground zero. So if I wanted the first item in the list, I would grab the index at 0. So what's the first thing that is in that list would be 2. Let's do another example, which I think is more appropriate. Let's do a P equals, let's just call it names. I'm going to call it blah, 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 Gary and Brenda, which is my girlfriend, and our dog. Let's do it like that. Set it up. Yep. And by the way, our dog we were thinking about getting a sister for her, and we're going to call her Sorta. So that's a funny joke. Not to anybody. Not even my girlfriend's laughing at that one. But anyway, so what we're going to do here is we're going to do names. And what I want to do is I want to call out, let's say I want to get the kind of name, and then, let me see what I'm doing. Get rid of that. Let me spell it correctly. Put it all back. Make sure you call your variables correctly. And it's kind of, and notice here that it's basically overwrites that one. We want to get rid of this. So names, we can reference anything within that. And remember, it comes from 0, 1, 2. And of course, we can do another thing too, where we want to start from the back. If you want to start from the back, you can go negative, and it will actually. So if I go names, and then we go, let's go 2. So I can actually start from the back and call Brenda. So you can call from list from front to back. And here's a visual way to be able to see this as we're doing these numbers that are up here, 2, 3, 5, 7, 11. Start with 0, call the first one, -1, call the end. What you can also do is you can actually do what we call slicing, which I think we've done before too. You can access multiple values in a sublist, and you indicate a colon to indicate the start point and that kind of thing. So if we wanted to be able to say, okay, I want names, and I want all of the, starting from 0, I want 0, 2, 3. I should be able to bring my entire list out. Cool. And if I only want to start with 0 and I only want to go to 1, it will only show me the first item that's in that list. So I can do slicing from that. And if you don't even want to have to define the 0, you can just by default just say name, 2, and whoop, sorry, I messed something up. I always keep mistyping that. There we go. And so it starts from 0 and goes to 2. So it's by default. Is it it's possible to specify a third integer. And so you can see it's over and over and over. We can do those things. Now, tuples. Tuples are exactly like lists, except they're immutable. So once you define a tuple, it is set in stone. Examples for that would be, and I want to show you something I just built, which I think is very cool example, which I'll show you. But a tuple, the difference between a tuple and a list list is in parentheses, a tuple is in, a list is in brackets, a tuple is in parentheses, and it's immutable. And so once you define it, you cannot redefine it. So for example, if I wanted to go tuple, and then I wanted to go t equals, let's say 2, 3, 4, should give me, let me see, make sure that let's see here. Redefine, okay, so we've set that up. And we're going to set it, and we can set the length. This means that once you create it, yeah, so for example, we cannot, once we set up that tuple and define it, you cannot go in and modify and edit and change while that tuple. You can redefine the tuple completely or delete the tuple, but you can't insert and put things in there. And let me give you some examples. So what I did was, for everybody that's here, on the GitHub location, I put like a secret location of stuff. And you should have already downloaded it, so it should already be there. But if you look under Python, there's a real-world directory that I put. And I'm going to start putting real-world examples of how Python can be used with lists, with tuples, those kind of things. So for example, and I also give examples of where companies are using Python. SpaceX, by the way, primarily uses Python for most of its rocket launches. And there's actually a link to the modules that they use. I put that in there so you can actually see the packages and repositories that they're using around SpaceX launches. Pixar has an entire package platform that they use for Python to be able to render and create animation. I put that link in there too, so if you wanted to be able to check out and be able to play around with and they're all open source. And of course, Instagram and Pinterest as well, they have packages that you can do to be able to create and have APIs to Instagram and Pinterest. And we're going to be talking about this probably in a couple of weeks. They basically used Django for its web application for both Instagram and Pinterest we'll use. Now, examples. Lists are really good for basically for NLP. So if we're basically breaking down text to be able to do translation, especially if we're doing translation from Chinese characters to actual, the Chinese characters or kanji characters from Japan into actual English words or letters or that kind of thing. Lists are really, really good at that because they can be redefined. Especially one of the things to note is when you're using Chinese or kanji characters that especially in Cantonese with Hong Kong characters, a combination of certain characters could mean someone's name, or it could be a derogatory statement. So you would have to redefine that, especially in Cantonese. I think there's 42 words for the word a penis in the Cantonese language, and it's just different combinations, and most of them are, but there's no word for vagina, which is really funny. So when we did vagina monologues, it was hard to create a Cantonese poster for the vagina monologues. Anyway, I said all of that you can use lists to be able to redefine, do some natural language processing for that. So that's an example for that. Tuples are really good for coordinates. So I just put this in so it's incorrect, but if you wanted to use GPS coordinates, those things where you set the list of these are the GPS coordinates and we want them to stick, they can't be redefined, which is, I think, is really, really cool. We're about to do sets and dictionaries, and we'll get to that. So what we have here is tuples. Dictionaries are exactly what they are. They're basic key value pairs. So instead of having it in a list and you have to reference it, you're basically saying the letter, the word one represents a number one. The the word 2 represents the number 2. So there's indexing around that. You can do that with names to social security number, passports to your former name, those kind of things. And you can access dictionaries. And how that works is curly brackets. So if you see a curly bracket within Python, that is a dictionary that is being defined. So parentheses is basically tuples, brackets are lists, dictionaries are curly brackets as you look at dictionaries. And one of the examples that I have in the real world thing that we set up here for dictionaries is passwords. Of course, you never put your password out in the open, but what you can do is you can actually do a nested dictionary where you can have an account, you can have a username, and you can have a password. And that's kind of a real world example of what you could do. You do a pull, put it out there. Of course, you wouldn't put it in clear text, you would encrypt it, but I just wanted to show that as an example of what a dictionary can be used for. And sets. Sets is, so as we said that what's cool about dictionaries is you're using curly brackets and you're doing key value pairs. This references this references this. Sets are very similar to lists, except they use curly brackets, but it's not a key value pair. So it basically contains unordered collections of unique items, and they're defined much like lists and tuples, except they use curly brackets of dictionaries. So for example, you can do references to be able to pull different items from a dictionary, pull in from a set, which is the key for that. There's also collections, but we don't want to go into. So what I've done for everybody, because I don't want to waste any more time, because I think we're at the top of the hour, and I appreciate everyone being so quiet and so patient. And I know I'm talking fast. So for anyone that's English isn't their first language or whatever, and they're like, what the hell is he talking about so quickly? Please feel free to ping me. But I did create some cheat sheets for you. So if you look here at the bottom, I've created 4 cheat sheets. So when you talk about lists, I have a cheat sheet for how you can create lists. So how you can create one, you can do links, you can do appends, you can do inserts, you can do removes, you can do append and extend, you can do deletes, the related keywords that are in Python with lists, list reverse, list sorting, string split. I mean, I created a whole cheat sheet with examples all the way through this. So there's list comprehensions. So because there's a lot of Python documentation, but it's a pain to be able to find what you're actually looking for. So I just created this cheat sheet so we can all use, and this is an easy one just to print out and have for you. I've done the same thing for tuples. So these are all the examples of tuple creation, accessing elements, changing a tuple. I've created a whole cheat sheet with examples on how tuples would work. And then I've did the same thing for sets, how a set would work, how you can create it, add an element to a set, that kind of thing. And then, of course, last is dictionaries, how you define a dictionary and those things. So that's for you to use and, add to it, change it, modify, but I did give that to you so you can get some, it's a little bit easier than trying to look up all the documentation on how do I do this and how do I do this. Okay, so now, final, I do have some exercises. I've started these exercises, but I have not finished them. So I wanted to kind of give you some examples if you want to be able to play around with this. So the first exercise that I want you to start playing with that we'll start hitting on when we talk next is get a space-separated list of integers from a user, create a tuple of those integers, then compute and present the result of a hash of that tuple. Now, what is it? I've also linked to the hint, so how hash works, and I've given you some examples of how that works. This is not the correct answer. I've just given you some sample code that you can kind of use as a reference to be able to go through it. But we want to be able to get a set of integers, create a tuple, and then compute the result of that hash of that tuple. And that's the first exercise. And like I said, you can cheat. This is open book tests all the time. You can Google it, be able to go through it. The other one is take a following 2 lists, and we're going to create a third list by picking an odd index elements from the first and even element from the second. and create a third list. So that's the goal for this one, is to create a third list, and I've created some sample code there, not completely corrected, but it's close. And so I wanted you to be able to see if you can change that, modify it to make sure that it all works together. So taking one list, taking the odd, one list, taking the even, and creating a third list. And then take the following list, this is exercise 3, slice it into 3 equal chunks, and reverse the list. So that's the goal. Created some sample there. Some of it works, some of it doesn't, so I wanted you to be able to feel free to change or modify, do that. And iterate through a given list and check if a given element already exists in the dictionary, and if it does exist, delete it. So that's the goal, is delete it from the list. So I've created these two, and what we want to do is we want to give a list, check if a given element already exists. If it does, you want to delete it, which I've given some samples in here as to get started. But it's not finished, but I wanted to make sure you had kind of a Kickstarter to kind of play around with it. And that's it. That's all I wanted to kind of cover today. We covered a lot, super fast, but I know all of you are super busy and you're brilliant anyway. You're a lot smarter than me, but I did want to kind of get you going. And so what we're going to be doing for the next class on next Wednesday, is the first 5 to 10 minutes. What we're going to do is we're going to go through these exercises, and I want you to provide your answers if you can. I'd like to see how you guys are filling this out. And then the next thing we're going to be doing, I already provided it for you, we'll be doing control flow. So we'll be doing if-else type statements, and then we'll be doing functions and error handling for the next class. Any questions? Any issues? Super fast, but I honor your time, and y'all are a lot more billable than I am, so I want to make sure that that's well known. And also, I use this as an example just to tell everybody I love all you guys, and I'm glad to be part of the QLX family with you. Any questions? It'd be funny if I was on mute the whole time and nobody heard anything. Hello? Is anybody there? Yeah, great. So great question. So I'm glad you brought that up. I would have totally forgot to say this. So let's take this one for example. This was our mod 1 that we had. So there's 2 ways you can do it. You can basically save this as, and I can say answers, mod 1, and just say Gary. You don't have to do module 1. That was an easy one just to get started, but the next exercise, and IPYMB. So I'm going to save that. And what you can do is you can do 2 things. There's an easy way and a little bit harder, but the better way. I can go to that directory, go into the QLX Python mod 1. Where did I save it? Here it is. Let me get rid of these because those don't matter. So I saved it as this answers mod 1, and you can just email it to me. That's a simple way. But if you want to do it correctly, so all I did was I did a save as, named it there, went to my Windows Explorer, my file manager, and I can basically send that in an email. Super simple. Or the cool way to do it, and the correct way, if we want to try to get into a habit of it, is using GitHub. And what you would do with that is, and I put some examples, and I'll do that in front of you. What we have here is, if you go to the GitHub location, I put this example of being able to have to create your own GitHub repository, so you can put your answers. So let me do that for you while you're here. So in the data science location here, and let me put this in your chat, and I'll put it in your Slack as well. Here you go. Put it as an answer. So here is the GitHub script, and I'll put this in the thing. What we want to do is we basically want to create your own account within GitHub, and then while you're in your own account, what we want to do is we want to create a new repository, and I'm going to call this Python Answers. I'm just doing this in front of you. And this is all documented in that link I just sent you. I'm just going to say Python Answers, and then I'm going to say keep it public. All this is doing is going to create a text file just to keep that open, and say create the repository. And this is for all of you. If you want to do this, this is a little bit harder. And then once it's created that repository under your GitHub account, then you just want to say click on the arrow down. You don't want to download it. You basically want to get this URL, this whole URL here. So I'm going to say Python Answers, and I can copy it into my thing. Then what you do, and let me open up a tab. And again, I just want to reiterate over and over that I have written this out. Let me just go to, before I start answering the questions. And go to data science. So basically I'm here and I'm just following this, these images and these examples. And now what I'm going to do is I'm about to run these commands from here. So what I want to do is I want to, I'm going to go to Documents, to Repositories. Oop, spelled repositories right. And then what I want to do is, notice that I've gone to the directory. I want to do a git clone. Now what it's done is it just pulled from my GitHub. If I do an ls, I have a directory there called Python Answers, and then I can go into Python Answers. It has a README file, and let's say I want to, okay, so now that I have that directory set up for me, what I can do is I can take this answers file that I have, and I can put it in my Python Answers folder. So I just did that. And in the future, I can also always save it to that directory. So let me show you. So if I go here to QLX master, go here, I have a Python's directory, and then I can save it into that directory, and there's my notebook with my answers. Now that I've saved it, it's in that directory, how do we push it up to GitHub so I can check it out? Super simple. Let me just go back. So what I want to do is, I've just added that. Okay, cool. All you have to do is you have to tell it, okay, I need to be able to add it as a command to be able to do a remote add. So I'm going to do git remote, git remote add, which is the command there. And this little piece I'll make into a video so everyone can see as well, because I'm recording this. But what I'm going to do is git remote add, and call it Python Answers, and and what you need to do is for the Python Answers, you need to take this this location, it's here, and put it that way. Cool. Now all we have to do is, and I do want to go back so you can see the code, we do a git add. You have to put comments on there, or commit with comments, and then you do a push, and now you'll see it show up. I'll show you that. So I'm going to do a git add, git comment, this is my Python Answers from module 1, and then git push, boom, there we are. Now what you'll see is there's my Python Answers repository, and there's my notebook. And what's cool about it is if all of you create these GitHub repositories, all you have to do is send me the link to your repository, and then I can keep up with it every week. You don't even have to tell me that you posted. I'll just look at it before we do the class just to see what your answers are. And what's great about it is I can just download it and be able to check your answers. Or if you have any questions, you can push something and I can go check it out at a different time. And so that's the long answer, or you can just email it. I don't prefer the email, but yeah, that's how we do. Does that help? Or is that, you got it? Okay, you know what? I am so tired of my own voice. And that was only an hour. Be glad that you're not doing my 3-hour course on Tuesdays and Thursdays. Whoa, that's hard. So that's it. I think that's all I wanted to say. Any other questions or any other issues as we get into this?